All right, so file formats. When we're creating those file derivatives, I already mentioned a couple of file formats. It's very common to use different file formats for different kinds of derivatives. It's common to use different file formats for all kinds of purposes on computers. So, for example, when we're making derivatives from a TIFF, we will probably make a JPEG out of that. If you have a video file and you want to make an access derivative, you make an MP4 from that. If you have a Word document and you want to make an access derivative, you would likely make a PDF. You could make other choices there, but the key thing here is that we're transforming from one file format to another. Now, understanding a file's format is an important aspect of understanding the type of data that may be contained in the file and how the file might be used. However, knowing the format of a file is not always a very simple thing. So one hint that we often use is the series of letters that you see at the end of a file name after a dot or potentially on the icon of a file. They're so ubiquitous that many of them have become the common name for a format. So for example, we have TIFF, T-I-F-F, that actually stands for tagged image file format. And most TIFF files have .tiff at the end of them. .pdf you're probably familiar with. That is short for the portable document format. .mp4, well, that's actually not an acronym. That comes from a couple of things, but it's the Motion Picture Experts Group fourth standard. So MP from Motion Picture and 4 from their fourth standard that they put out there. MP3 is also from the Motion Picture Experts Group, but it's actually from their first standard, but the third version of an audio codec within that standard. So these patterns are always a little bit strange. JPEG, again, that does stand for something. It stands for the Joint Photographic Expert Group that came up with the standard. However, most JPEG files are actually JFIFs, which is the JPEG file interchange format. That is the actual specific format that they defined to hold that, but for whatever reason, JPEG became the extension that became attached to that. And now you may notice that as you copy files between systems, the extensions may appear or disappear over time. And for example, if you copy a file from a Mac to a Google Drive, a file extension suddenly appears in the Google Drive representation. And that's because some software companies try to hide that information to protect you from changing it. Because if you did change it, it wouldn't actually change the file itself, but it might end up confusing software that is intended to work with the file format. It's one of the weird things about file extensions that they are hints, but they are not actually defining anything, but at the same time, they're so useful that some software actually ends up relying on it to understand, what this file might be. And, every tech company makes a different choice here because file formats are very, very slippery kind of a topic. For example, .tiff, if you saw that at the end of a file name, well, there's still a lot of information that you don't know about that file. Yes, it's probably a TIFF, but TIFF has 4 public versions, version 3, 4, 5, and 6. It also has a couple of variants like GeoTIFF, which is a TIFF version 6 with embedded geospatial data, so you can import it into your geographical information system software. There are things like TIFF/EP, which is there for electronic printing format for layout. That was very common in the late 90s and early 2000s. There's another one called TIFF-IT, which was an adapted format to be better, more useful for high-end digital cameras, to be taking raw photography and things like that. So yeah, unless you know a little bit more, unless you do a little bit more digging, those 4 letters at the end don't really tell you like, oh, what could be inside of there, right? It could be pretty specialized. Those letters at the end also, I mean, a 3 to 4 letter name, you can imagine a lot of those extensions get reused. And the situation for doc really exemplifies this. .doc was used by over 20 different pieces of software. So Microsoft Word is the most common, but WordStar, Lotus Write, Perfect Office, Scribble, some of these you might have heard of, many of them you probably never have heard of, but .doc, yeah, it sounds like documents. So a lot of companies use this for their extension on their file format. And these are not the same thing. You know, a WordStar.doc is not necessarily going to be really renderable, or at least correctly renderable, inside of Microsoft Word, and vice versa. And then there's also the problem that many formats can have multiple correct extensions. Like I've talked about JFIF or JPEG or whatever you want to call it, and I've been using the example of JPEG. But sometimes you see those files and they say just JPG at the end. Sometimes you see those files and they say JPG, but it's all in caps. Why all these tiny variations? Well, it comes down to a little bit of history, but the first thing to say is that it doesn't matter. Like, this file extension is a hint. It doesn't define the data. You could change a file's extension from JPEG to JPG to capital JPG, whatever you want. The data inside is not going to change in any way. And it's a lot of like social practice that determines what kind of extension that we're using. But back to the reason, why do we have some of these differences, especially this weird thing about file formats that have a 4-letter long extension and also a 3-letter long extension? Well, that particular problem goes all the way back to the 1970s and the invention of something called the file allocation table file system, which was used to manage the data stored on floppy disks in the 1970s. Now, as you can imagine, a floppy disk in the 1970s is a very, very small amount of data. And so the file allocation table was very, very parsimonious in how it used that data. It didn't want to allow you to have extremely long file names because you'd end up using the actual storage of the disk itself and not being able to store as much data. So, in being very careful about data usage, it actually only allows 11 characters for a file name. 8 before the dot and 3 after the dot. And on this slide, you see an example of what a file allocation table looks like. Especially those first 2 columns, you'll see there's the file name and the file ext. And first column is limited to 8 characters, the second column is limited to 3 characters. Now, other file systems didn't have this limitation, so you would run into situations where, say, you're working on a Mac and you create a JPEG and you call it something like 0001.jpeg, and then you copy it over to a Windows system that's running a FAT file system, and it would be changed to 0001.jpg. And that's completely fine because, again, the extension doesn't matter. The data is still being transmitted correctly, but the FAT file system wasn't able to actually render that extent or to keep that piece of data exactly the same when it comes to the file name. So, yeah, this is entirely a cause of a issue from the 1970s with floppy disks. I think the funniest part of this is that the JPEG file format was invented in 1991, so this whole problem was created 13 years before it ever existed, and it never had a chance of having just one file extension. Like, it was always going to be bandied about between these systems. Now, all that's to say that extensions are often a very good hint, but they are not, you know, the most exact way to identify a file format. They can be unspecific, they can be vague, they can be confusing, they can be potentially just wrong. You could change the extension on a JPG to PDF, and guess what? It's still a JPEG file on the inside. Sometimes there are features within the bytes of the file that can help us determine a file format more precisely. So for example, here I have the first 12 bytes of most JPEG files, what they look like, and you'll notice that there are 4 bytes in here, 4A, 46, 49, 46, and those 4 bytes can be decoded via ASCII to JFIF. So a lot of JPEG files within the first 12 bytes say this JFIF thing, and we can use that to self-identify the thing as a JPEG file. That's not going to occur in a lot of other files. But this isn't a universal practice, and everybody does their file formats a little bit differently, and so in the end, we have to accept that there's just simply no universal definition of what a file format is. Still, it is a useful concept to keep in mind. So when you're identifying file formats, because you need to do that for your job to understand, you know, what are you accepting or what are you trying to make accessible, be flexible in what you are identifying. Sometimes it's okay to know that, you know, this file is a PDF. Sometimes you want to know that it's a PDF/A version 1.7. Sometimes it's enough to know this thing's a document. It has textual information, and I don't want to go into the details. In every one of those situations, you'd probably identify the thing that you are calling it as the file format, and you'd be right in all of those situations.